Okay, guys. So this is that tree diagram. Everybody seems to be well. Not everybody. There's a few little struggles here and there. Basically, I think you guys are doing just fine with this. Just I think sometimes the way they ask the question. So they're going to ask the question using A, not A, B, not B, and then just give you a bunch of numbers. Let me throw some numbers in there real quick. Let's go with let's go five. Whoa, whoa. Sorry. 5, 10. Let's go 8, 6. So, being that we know how tree diagrams work, if I work my way backwards, this should be 15 and this should be 14. And if I keep going further back, the the grand total, the sample space is, or the sample size is going to be 29, right? That's the sample size. But that didn't seem to be bothering you guys so much. You guys seem to be fine with the sample size. I think what was bothering you guys was the way we were saying the ands and the ors. But let me go through all of this, okay? Let me make sure that we're cool with all of it. Let's go. What's the probability of A? If I say what's the probability of A, well, that's really just going to be all A over total. And all of A, well, there's 15A. So it's 15 over 29. And it's really this part here, how you were interpreting this statement. That's what's really important. I think if you can get here, that will come a little bit more naturally. Let's try this. Probability of B. So I want all B over total. So all of B, let's see. Well, some of the B's came up here and some of the B's are up here. We have a total of 13 B's. And again, if saying the word or saying the letter B is throwing you guys off, then give it some meaning, like what I did up here. I said, what's the B represents wearing a hat. What's the probability of choosing somebody who's wearing a hat? Well, notice, let's do this real quick. This right here, this line is the probability or is the number of people wearing glasses and wearing hats. So that's A and B, right? Um, where was I going with this? So if I want to interpret this, the number of people wearing glasses and not wearing hats, this would be A and not B, right? Down here, this would be not A and B. These are people here that are not wearing glasses, but they are wearing a hat. So it's not glasses and wearing a hat. And then finally, down here, these are the people not wearing glasses and not wearing a hat, right? So if I say, what's the probability of B? I could be thinking to myself, what's the probability of choosing somebody who is wearing a hat? So there are uh, 5 people up here wearing hats, and there are 8 people down here wearing hats, so that I have a total of 13 people out of 29 wearing hats. All right. Okay. So, like I said, if you can interpret this just fine, this will follow through. Just think it through. Now, I realize that's still not answering the bigger questions, the ands and the ors. So let me erase this. Sorry about that, but I want to keep my space here. Let's try the probability of A and B. All right. Well, the probability of A and B, as we saw just earlier, if I follow this trail, these are the people who are wearing glasses, right? All these people wearing glasses. And then I split them up and say, among you people wearing glasses, here it goes. Among the people wearing glasses, how many of you guys are wearing a hat? So hat and glasses is 5. I have 5 people wearing a hat and glasses out of 29. And there it is. All right. And of course, you watch the other videos, you can turn that into a decimal or a percentage, and you're all good. I don't think you're going to need to do that for the test, but all right. What if I said, what's the probability of A or B? Well, now this is a little bit different. This is the union, right? I want to count everybody who's wearing a hat or has glasses. I don't care. The only people I don't want to count is anybody who does not have a hat or glasses on. So, or so let's see. Probability of A and B. A, there are 15 people wearing glasses. Now, mind you, that's already taking care of these guys, right? And these guys. But among the people who are not wearing glasses, the 14 people down here, there are still 8 people who are wearing a hat. So when I say A or B, I don't care if you're wearing glasses or a hat, you're coming to the party. All of you are coming. The only people that can't come to this party, which seems like a strange thing to say, but the only people that can't come to this party are the people who don't have a hat or glasses. So we have a total of 5 plus 10 plus 8 over 29. That's going to be what, 13, 23? 23 over 29. And again, turn that into a decimal or a percentage, whatever you like. All right. I hope this helps. I hope this is putting things into perspective. Read this a couple times over. If you want me to do a couple more of these particular ones, just let me know. Maybe I can do that tonight or tomorrow and send them out. All right. Take care, guys.